We'll take a look at the practice test for Module 3. There's only 10 questions. Again, I'm not going to give you the answers, but we'll show you the strategy. So let's get started. So for something like this, again, a strategy similar to what we did in Module 2. We want to find values when r is 0, a 3, and a 7. So what we do here for each of these is to substitute this in there and get our different values. So I've copied the formula and put the 0 where the n is, 3 where the n is, and 7 where the n is. And now we just need to simplify this, and then of course put our values in there. On this one, again, they're asking a question that we've had before. We want to know the domain of a function. So the domain of this function would be all real numbers, but s could not be a value that makes our denominator a 0. Now, I don't know if you see you have conjugates here, and you're going to find the zeros. Again, what values would make this denominator a 0? They would be excluded from the domain. Now, here they're asking us to multiply and simplify. But before we multiply, we need to factor. So let me give you a few hints about this. And again, I'm not sure how far I'm going to go. I don't want to give it away. But we definitely want to give you the pattern of what your examples might be like. Well, this is a start. What we're going to take out of this top item here is a 3, and it factors into this. Now this bottom is interesting because it's 4 minus a squared. Well, as you see what we're formulating here, if we take a negative 1 out of there, we can switch this around so it looks like this. This is now the difference of perfect squares that will factor into its conjugates. So there's one of the conjugates there. But keep in mind, don't lose track of that negative 1. This has to have the signs put in. And out of this one, we're factoring a 3. So you see, you can do some cross-canceling eventually, but this is the pattern of what you need to do. Here again, we're asked to divide. There's our division symbol. And remember, when we divide fractions, we change it to multiplication, and then flip this. That is, take the reciprocal of this. So now this is on the bottom, and I've factored a 4 out of that. This I'm going to factor into its conjugates. This is a perfect square trinomial, if you remember. And here, this is just regular factoring, but this trinomial will be factored up here. And that's what you need to be able to do. Factor each of these correctly. Don't forget to flip them. changing division to multiplication. Now in this example we are adding these rational expressions, these fractions. The rule is if the denominators are the same, which they are, you just put your numerators over the common denominator. Now what we need to do here is group like terms, and we're going to get something up there as we group these like terms. Now notice this can be factored, and you want to see if when you do factor this and combine like terms whether something will cancel out. And I believe something would here. So that's the challenge of this. So after studying this example, here we see the denominators are similar, but they're not the same. The signs are wrong. So what I decided to do is to switch this term with this term. We're allowed to do that. And in this term here, I'm going to take out a -1. And this will make this a minus, and this will make this a plus. And then I'm going to switch these around, so this becomes A minus B, and my negative is here. Now I can have a negative there, I could have it up there, and that's what I'm going to put it. So I'm going to erase this positive here now and put that negative that I took out of there right there. So now I have this, a squared minus b squared over, now my denominators are the same, a minus b. And I don't know if you can see this, but this is the difference of two squares, which will factor into its conjugates. And then you simplify. I may have given away too much on this one, but well worth it. Now, this is a rational equation with fractions, and we are asked to solve it. Now, we had said back in Module 1, anytime we have fractions, we need to multiply each term, and there are 3 terms in red here, by the lowest common denominator, which happens to be 2y. So I'm going to multiply in blue each term by 2y. So here, these cancel out. Here the y cancels out. And here the 2 cancels out. So now I don't have fractions anymore. I need to multiply through with whatever's left. I guess I can do that for you. This is going to be a 3 minus 2 times 3 is 6 equals, again the 2 canceled out, not the y, equals 3y. So once again, the original equation is in red. I'm multiplying each term by the lowest common denominator. And here I end up with a 3. Here I end up with a -2 times 3, -6. Here the 2's cancel out, and I end up with 3y. And I'll let you solve that. Y is going to equal something. So in the last one, it showed the technique that we would use with rational equations. We need to get rid of these fractions. So I've copied it, but over here I factored this into that. And if you see, it is these parts here. So what I need to do here is to multiply each term by the lowest common denominator. And another way we sometimes do this is put a big bracket like out there, and then we're going to put our items that we're going to multiply each term by out here. So I'm going to cancel this out with this one. So I have to multiply this one by x plus 2. I'm going to cancel this one with this. So I have to multiply the 3 by x minus 6. And the nice thing here is that now both of these will cancel out. So this, we have now just ones in our denominator. So we're going to distribute this, combine like terms, and solve for x. We're going to do a little background on this. Here we're dealing with inverse and direct variation. This is the formula if it were direct variation. Y equals kx. For inverse variation, it's y equals k over x. So the pattern for solving examples like this is, say, it says that t, we're going to put a t where the y is, varies inversely. So we need the k as to the number of people working to do something. So this would be, I guess we could use p here. So the first thing you have to do for something like this is find what the constant of variation is. So for time, it's 2 hours. And 7 cooks. So instead of people, we could have put cooks there. Now, what we do here, we can just cross multiply, and we find out that our k here is 14. So now we know our formula, t equals 14. We replace the k, and now we want to know how long it's going to take. So we are going to use now 3 cooks. So how many hours? Now I could tell you what the answer is, but I'm going to let you figure this out. And on that last one, an improper fraction would be perfectly okay. All right, let's take a look at this one here. The stopping distance d of a car after the brakes are applied varies directly as the square of the speed. So we said for direct variation, this was y equals kx. So we're just going to convert this now. So the distance would be d. We need the k. And it varies directly to the square of the speed, which is going to be r. And the square of that we would write like so. So the first thing you'd have to do is take your information, 70 miles per hour, Well, we need distance first. So that's going to be 270 feet. Car traveling 70 miles per hour. That's its rate, is squared. So they're then asking how long or how many feet will it take the same car to stop when it's going 90 miles per hour. Again, you have to find out what K is first. So you solve for K, and then the next time you're going to put your value for K and your rate 90 that you're going to square, and then you're going to get your new stopping distance. Okay, that's our last example, I believe, and hopefully this gives you an idea of what Module 3's test would be like. And as a postscript, I might add that here it's to the nearest whole number. So the nearest integer, they don't want decimals.